Okay, lesson 8-B, percent change in estimating. This is the combo of lessons 8.5 and 8.6 on page 416 and through 421 in your book. And what are we talking about first? Percent change. Well, percent change can follow a very simple formula. Take the amount of the change, something has happened, how big was the change, and then put that over the original amount, and that is called the percent change. So if that original amount got bigger, then you call it a percent increase. If the original amount went down, then it's a percent decrease. Pretty simple formula. And increase if it goes up, call it a decrease if it goes down. So how do we do that? How do we use that? So what if we're given a problem that says find the percent increase or decrease of a situation? And here's our first situation. We're starting from 20 to 24. So first you find the amount of the change. So you take the big number minus the small number and you get 4. 24 minus 20 is 4. And then you put that 4 over top the original amount. Well, which one of these two is the original amount? It's always the one that started from. Okay, so they started from 20 and they went to 24. So now you can see that I could divide the top and the bottom by 4, and that gives me 1/5. And 1/5 is just 0.2. When I change that over to a decimal, and then I change it to a percent, and it's a 20%. Now, is it an increase or a decrease? Well, once again, we take a look at that starting point, and where did we end up? We end up smaller. So since it was smaller, we ended up bigger. 20 to 24, it was an increase in the overall size. Okay, so that would be our answer, 20% increase. So the second problem here, we have starting from 80 and going to 4. Okay, so very first step we do is figure out the amount of the change. Take the big number minus the small number. That means 76 is our amount of change. We put that 76 over the original amount. The original amount is the 80 here. So there's where our 80 goes. And then we just hit our calculator. Our calculator says, well, that's 0.95. I move the decimal place over 2, just like this, 1, 2, and that gives me my 95%. And because this was bigger and got smaller, then that is a decrease. So our final answer on this one is a 95% decrease. What if we're calculating prices using a percent increase or a percent decrease? Okay, so we have an original monitor price. I want to go in and buy a monitor for my computer. It's $750. It's a really fancy monitor, but it's being reduced by 35%. I need to know the new price. They didn't put it on there. I want to calculate the new price. Well, first thing you do is you calculate the reduction. Well, how do I know what to do? Okay, so this 35% we know to change to 0.35. Okay, we take our original amount and multiply it times our reduction percentage, and this tells us the amount of the reduction. That doesn't tell us what we're looking for. We're trying to find the new price, but we do know the reduction. So now let's just subtract the reduction from the original price. The original price was $750. The deduction comes from our first step. We subtract it out, and we end up with an answer of $487.50 as my new price. So we know that the $750 monitor reduced by 35% is going to cost us $487.50. And that's a reduction. Now what happens on an increase? Let's say you're the owner of a furniture store and you have sofas that you sell pretty good, a lot of them. They cost you $366. How much should you charge your customers so that you can make a good profit? Your internal markup percentage is usually 33 1/3. Okay, 33 1/3 being, 0.3333 repeating forever. And you want to, if you add that markup, that's what you put on as your retail price, the price that you want your customer to pay. So first you're going to calculate your increase. Well, I know that 33 1/3% is basically the same fraction as 1/3. So I just changed that 33% to 1/3. Now, instead of multiplying by a decimal that we did in the previous problem, this time I say, oh, I got 1/3. I multiply that times my original price of my cost of my sofa, and it's really just 366 times 1 divided by 3. So I divide 366 by 3, and I get $122. So now I have to add that increase back to my cost. There's my cost, came from my original problem, cost. Then I add my 122 increase, which I calculated right here, and I get my new price, the retail price, the price that I'm going to charge the customers for this sofa at $488. Now let's talk about a little bit of estimating. When you have percentages and you're trying to estimate, a lot of times you can see some compatible numbers. For example, if I have this fraction, 13/24, and I'm willing to estimate, I can easily see that if I just change that to 12/24, those two numbers are compatible. In other words, that makes it perfectly, 12 is perfectly 1/2 of 24. So once I make that change to a compatible number, I can then just estimate that 13/24 as 1/2, using it, that it is approximately 1/2. So then I could just use 1/2 in my calculations, which is a lot easier than 13/24. Okay, so given that example, we're saying, what is 26% of 48? Well, first thing we remember is that the of sign, right, is a multiplication sign. All right, well, let's just do it right here. There's the of, and we're going to have to do some multiplication. So now what are we going to multiply? Well, the first thing we want to multiply is this 26%. But I'm going to say 26 over 100. I'm going to use a compatible number. That's 25 over 100, because I know that 25 over 100 reduces to 1/4. So 26 over 100 is approximately 1/4. And I put that there. Then my number 48 is easily multiplied. It's compatible, basically, because I'm going to take 48, divide by 4, and I end up with an estimate of 12. So 26% of 48, using an estimation, is approximately 12. The next estimation here is 14% of 20. Once again, we have the of word, so we know we're going to do a multiplication. So first thing I do is I say 14%. Well, if I did 15%, I then get 15 over 100, which can be reduced to 3 over 20. And oh, by the way, I see that I have 20 here, and 20 is one of my numbers, so that's a very compatible number. So now when I take 3 over 20, which is my my approximation of 14%, and I multiply it times my original price of 20, I'm just going to be able to cancel the 20 on the bottom of the first fraction, and the second fraction be 20 over 1. I'll just write it like that, and I can cancel that to 1 and that to 1, and I end up with 3 over 1 times 1 over 1, or 3. So approximately 14% of 20 is 3. And finally, let's say we're given a problem that says, figure out this waterfall height if we know that 173 feet of Niagara Falls is approximately 5.3% of the Angel Falls in South America. So it's a very tall waterfall. So what we're going to first do is say, well, maybe both of these need coming down. Well, I'm going to change 173 to 170 just because it's a lot easier number to work with. And I'm going to change 5.3% down to 5%. So when I do that, I now have the problem of, 170, which is my part, okay, because 170 is the small part of the waterfall, and I need to find the large part, the whole. And if you remember from the other day, then we just multiply times 5%, change the percent to a decimal, 0.05, times our whole, or the height of the one waterfall, 5%. We then divide both sides by 0.05, and we end up with 3,400 feet. So the estimated height of Angel Falls is approximately 3,400 feet, given that it is approximately 5% of the 170 feet that Niagara Falls is. Now let's do some quick problems. Let's try to find some of these here and do these. Let's see, find the percent increase or decrease. So let's do this in red here. We'll do this in red. First, you find the amount of change, 16. Let's not be so large there. Let's come down here to that. And let's erase quick. There we go. Now, we'll say 16 minus 12 equals 4. So we know that this is my amount of change. I'm then going to put that in a fraction over the original amount. What's my original amount? Well, we went from 16. I can then divide the top and the bottom by 4 to simplify this guy, and that equals 1 over 4. So I then change that over to a percent, which I know that from the common fractions, that 1/4 is 25%. And now, is this an increase or a decrease? We went from 16 to 12. We had to get smaller, so that's a decrease. And we write that here. And that is our answer. What about the second one, letter B? We have a $450 tire. It is on sale for 20% off. What is the sale price? Well, we're going to use it just like we did above. In the example above, we're going to start with our $450, and we're going to calculate how much reduction it is. Well, 20% off means we're going to multiply times 20% to get that price amount off. But let's change that to 0.2. So it's 450 times 0.2. And when you do that, let me get my calculator out. That should be about $50, I'm guessing. Times 0.2 is $90. I was off. $90. So now to find out the sale price, we have to take that 450 original price and subtract the 90, which is our amount of our reduction. And when we do that, we end up with 6 and 3, $360. So the sale price of our tire is $360. Now let's do a little estimation. Let's give myself a little bit more room to do this estimation. And so first thing we're going to do is say, well, let's go ahead and do, let's change that to 20%. And we know that 20% is equal to 1/5, 1 over 5. So now we're doing the of 66. So we're going to go ahead and say that, let's go right here. We'll say 1/5 and of 66 would be a simple 66 divided by 5. And we punch that into our calculator. We get 13.2. Another way of doing this one, if you didn't mind, you could change this to 65, and then it would have 1/5 of 65, and that'd be 65 over 5 which would give us straight 13. So I would have accepted either one of these answers if you show your work. And finally, we have one here called the diameter of the moon. Insert a little bit more space, get it up at the top here. So we have the diameter of the moon is about 2,160 miles, and that is 27% of the Earth's diameter. What is the approximate diameter of the Earth? Okay, so this one kind of falls back onto some of the things we know. We could set up a proportion, okay, or we can set up many other things, but let's go with the proportion. Okay, so let's do this. We're going to say that we know the percent, so we're going to write on 1/2 of our proportion 27 over 100. Okay, but we could make that simple and make it 25, because we know that 25 over 100 is 1/4. Okay, so instead of using the proportion, now I have a simple number. 25 is 1/4. Okay, so now I could use a formula or a proportion to calculate that out. So if I use the equation, if you remember, this would be saying 22160 is 27% of what number? Okay, and that number we're looking for is the Earth's diameter. So if we set it up like that, then we look at our keywords. Is our equal. 27% is going to be written as 0.27, and of is our times, and the number is n here because for the variable. And if we were estimating, I would not use 27, I'd use 0.25. Okay, which is 1/4. 1/4 times n, which means that to get rid of the 1/4, we're going to multiply times 4. So our final value of the diameter of the Earth is 2160 times 4, which is 8640. If we would go ahead and use a proportion like I thought we were going to, I'm just going to go ahead and do it. That 1/4 is still our estimate of 27%. Remember, we're saying that 27% is approximately 1/4. So we're going to set that up. Now we need to part over the whole. Well, we know that the part is the moon, 2160, and the whole is the n. We multiply those across, and we just did it right here. This problem right here is 4 times 2160. So coming down to the left on our proportion here, 4 times 2160 is 8640, and 1 times n is just n. So if we label either one of these two with miles, mi, we now have our answer. And that's the lesson.